In this video, we will learn data and signals in the TCP/IP protocol suite. So let us start. The bottommost layer in the TCP/IP protocol suite is the physical layer. The application layer generates data, which moves down along the networking layers to reach the data link layer. The data in the data link layer is called frames. It is a final form of data which is transmitted in the network. However, it is a sequence of zeros and ones, so it needs to be converted to a form that can travel along the transmission medium. The transmission medium can be networking cables in case of wired communication or free space in wireless communication. The stream of zeros and ones is called data. It should be converted into signals to transmit it along the networking cables or free space. The physical layer converts data into signals. Both data and signals can be either analog or digital. Example of analog data is the information provided by an analog clock that has hour, minute and second hands. As time moves from 10:10 to 10:11, the clock hands show a continuous movement. That is, there is no sudden jump from 10:10 to 10:11. Such information, which is continuous, is called analog data. On the other hand, the information that has discrete states is called digital data. For example, the information provided by a digital clock, where the time changes suddenly from 10:10 to 10:11. The sound made by a human voice is another example of analog data. When someone speaks, an analog wave is created in the air. The microphone captures the analog wave and converts it into an analog signal. It is then sampled and converted into a digital signal. Finally, it is converted to digital data and stored in the computer memory as zeros and ones. For the transmission of stored digital data, which can be audio, video or text, it is converted to digital signals or modulated into an analog signal for transmission across a medium. So what are analog and digital signals? An analog signal has an infinite number of values along its path as it moves from value A to value B. Digital signal has a limited number of values as it moves from value A to value B. A signal can be periodic or non-periodic. Periodic signal is one which repeats the same pattern after a fixed time frame. For example, a sine wave. On the other hand, a non-periodic signal does not repeat over time. In data communication, we commonly use a periodic analog signal because they need less bandwidth, and non-periodic digital signal to represent variation in data. So in this video, we learned that the data can be analog or digital. Analog data is processed and stored in memory as digital data. The data link layer receives digital data like audio, video, text in the form of zeros and ones, and the physical layer converts it into signals for transmission across the transmission medium. If you have learned something from this video, then please like this video, share this video so that more people can learn. Subscribe to Tech Terms if you want to learn more and turn the notification icon on.